Hello and welcome to your second lesson for Honors Calc, Parent Functions, Domain, and Range. This is going to be part of our review topics. So we are talking about calculus, right? Calculus is the math that helps us describe change in our world. So I've got a few examples like rate of population growth or decay, the fluctuation of weather. You might recognize change in math as slope because you've got the change in y over the change in x, and that's actually how we're going to first see something that we've learned in previous math courses come up in calculus, and that's with tangent lines. So tangent lines will be our first calculus topic, but they won't appear until after we've reviewed these concepts, these pre-cal topics. So you can see them there. They're all essential for starting calculus. I've attached a worksheet here, and I'm not going to go through this whole thing with you. In fact, I think you'll find it pretty easy to fill out. I did want to make sure that you know all these 8 functions. You know the function equations of them, the zeros, the domain, the range, the vertical asymptotes, and then 5 parent points for each of these 8 functions. Now, on this notes page, I've given you all the information. I've given you parent points for these graphs. So I'd like you to fill out the graphs with those parent points and keep those as notes for this section. Things are pretty easy for quadratic and cubic as well. When it comes to the reciprocal function, this is where it gets a little funky. The parent points that I want you to know for this one, they're not just 5 of them, there's 6. So we're going to know -2, -1/2, -1, -1, and then -1/2, -2. And I'm going to go ahead and I'm going to change my scale so that every 2 units is 1 unit. That way my graph is a little bit easier to create. I can plot -1, 1 there, -2, -1/2 here, and so on. And you've probably guessed, or you might remember what this graph looks like. So we know that we're going to use these 3 other parent points. So there's going to be 1 at 1/2, 2, 1, 1, and 2, 1/2. So those are the 6 parent points for this graph. And I'm going to do my best to fill in this shape. The graph for this rational function or the reciprocal function has a vertical asymptote, which you might remember from pre-cal. This divides our domain. So the domain here is actually not correct either. So this domain is -∞ to 0, and we're going to use a union 0 to infinity for our domain. The range should be the same as the domain. So that's actually one that I messed up with on the creation of this worksheet, but you know now that those are the domains. Notice this little symbol, the U, that's saying I'm combining the pieces of my domain or my range. So I'm saying that this interval is part of my range and this interval is part of my range. Together they create the range. So that's why this union is creating that togetherness, that symbol. That means putting those 2 things together. But as far as the rest go, it should be pretty easy to uh, get graphed. The last thing I wanted to show you, you can fill out the exponential and logarithmic ones, of course, was the domain and range of functions. This is a short review. A function is a relationship where every input has its own output. In other words, the function has to pass the vertical line test. So we cannot have multiple outputs for a single input. So to clarify, I should say unique output. And domain, of course, is inputs and x values. In case you've forgotten, range is outputs and y values. Interval notation is something that I've already talked about. When it comes to this reciprocal function, it's written here for like the square root function. The questions I wanted to get into with interval notation are the domain of this piecewise function over here on the right, which is a piecewise is just two different, like in this case, parent functions that have been transformed, two different functions mashed together. The domain of the whole thing, so the domain where all the inputs are defined, is all real numbers, or if we use interval notation, negative infinity to infinity. So we know it's defined because we can pick any x value and it will return an output. Now the domain for the linear function, which I've represented with like subscript linear, is negative infinity to 0. But we are going to use not included. 0 is not included in the domain of the linear function. So I'm going to use a parenthesis here. For the square root function, 0 is included, so I'm using a bracket, but infinity or negative infinity will never be included for our defined range or domain. And the tricky part about interval notation, I think, comes with range. These questions are a little funky because you are used to looking on x, but what about on y? The range of the square root function is -1 to infinity. And it's important that you know a square root function, even though it looks like it tails off and doesn't increase anymore, it still increases. The square root of a really large number is still a bigger number than the one before it. So it will always increase. That's it for the video today. Make sure you complete this along with the videos. And I'll be talking to you in class. Thanks.